Lesson 18.2, Task 4. Find the probability of two independent or dependent events. All right, so as you look through here, you're going to see all of these symbols and letters. And when you read through these, you kind of have to make sense of what it's saying. You want to read and understand what it's telling you, not just saying the letters and the symbols out loud. So let's see if we can kind of interpret what this is saying. So it says, while you can apply the rule for the probability of independent events A and B, this is the rule, only when you know that two events are independent. So you're going to use this rule here, only when you know that two events are independent. You can apply the multiplication rule, this is the new rule that we just learned, to any two events A and B. So this is saying while you can only use this if you're certain that it's independent events, you can use this rule for independent or dependent events. So this rule covers a little bit more ground since you can use it for all. So even though this is a good rule, this is probably the best rule to know since you can always use it. All right, it says to see this, remember that for independent events A and B, substituting P of B for, and remember this is in one of the tasks, the conditional probability of BA, and we were able to substitute P of B in because it was equal in the multiplication rule. This gives, okay, and if you read through this here, which is just the rule for finding the probability of independent events. Okay, so what that's saying, it's just basically showing in symbols, mathematical language, that if you use this, it will work, okay? All right, so let's look at an example here. It says 160 high school juniors and seniors at a school were asked if they were working part-time jobs during the current school year or school semester. The results for the survey are shown in the table. All right, so you can see juniors, there are 80 juniors and there are also 80 seniors. There are a total of 59 students employed and 101 students are not employed. This row will equal 160 and this column also equals 160. So that's the information that's given. It says use the multiplication rule in two ways to find the probability that a student is a senior and is employed part-time this semester. Are these events independent? How do you know? All right, so we're going to use the rules that we were given to apply the multiplication rule. Use an expression for, all right, so this is the conditional probability of senior and employed, or an expression for conditional probability employed and senior. So you can see that they did switch the order here. All right, so the probability of senior and employed, so we've got 80 out of 160, so let's go up here and see. Seniors here, so we've got 80 seniors out of 160, so that's where that number here comes from. And 51 out of 80, so 51 seniors are employed out of the total 80 seniors that are here. So if you multiply those two events together and change it to a percent, you get about 31.875%. So that's employed and senior. So we're going to look at the other way as senior and employed. Okay, so if we do 59 out of 160, okay, so this is the number employed. 59 students are employed, so we're just switching the order around. We're looking at employed first, 59 out of 160. And then out of seniors, there are 51 seniors out of the total 59 that are employed. So 51 seniors, which makes sense. More seniors are going to be driving and have a vehicle to be able to work to do that. So that kind of makes sense. All right, again, if you multiply these numbers together, you're going to get 31.875. You can see that these two things are equal. So what they're saying is, you know, the multiplication rule is going to work for each of those. So it says, how is the probability of senior intersect employed related to the frequency of the two-way table. It is the joint frequency of employed and senior divided by the total frequency. All right, so that's the total frequency is like the total amount that it happens each time. So total amount altogether is 160, but also each excuse me, each column also has a total as well, and you can see each time it's divided by either the total amount or the total in that column. All right, so now notice that the probability of senior times probability of employed is 18.4375%, which is different than what we found here. Okay, so these were 31.875%. All right, so it says if the events were independent, what would you expect? Well, you would expect to get the same answer. All right, so what is the probability that a student is a junior and is employed? Give your answer as a whole number. All right. Probability that a student is a junior and is employed. All right, I'm going to pause this for a second so I can get my pen so we can write this down and work it out. Okay, so what we're trying to do is what is the probability that a student is a junior and is employed? So let's first find the number that is employed. Okay, so the number employed is 59 out of 160. So let's take that number and write it down. And then we need to know the number that are juniors and employed. So juniors and employed is 8 out of 59. All right, so we can figure out what that is by using our calculator here. So let's see what that says. So we're going to have 59 divided by 160 times 8 divided by 59, and that's going to be 0.05. So that is 5%. Now, I also want you to look and see that if you know that you're looking for juniors that are employed, okay, if you have this table here, you can see that this is juniors and this is employees. So that is 8 out of 160. Okay, so we just found that this is 0.05, but 8 out of 160 is another way to look at it if you have the table and it's ready and easy. In my mind, that's a little bit easier way to do it. So just thought I would show you that you do get the same answer if you want to use that as well. So anyway, so that is 0.05. So 0.05 is the same as 5%. So we can go down here and show that the probability that a student is a junior and is employed is 5%. All right, so it says since the probability of A and B is not equal to the probability of A times the probability of B, events A and B are not independent, but they are dependent. The probability that a student is a senior and is employed is about 32%. So right here we found junior and employed. Here it's talking about senior and employed. So that was back up a little bit further. So here the 31.875, this is about 32% are both employed and a senior. All right, so that's all for task 4. If you have any questions, let me know.